My dream as a scientist is to understand the basic building blocks of the universe, which are the quarks. And if you understand that, and also the strong force which binds them together, we're one step closer to understand the universe and how everything was formed after the Big Bang. Strong force is one of the 4 fundamental forces in nature. The other 3 are gravity, electromagnetism, and the weak force. And physicists are not very creative in naming things. This is why the strongest force is actually the strong force. And it is responsible to combine quarks together. So a quark is actually a very fundamental constitute of matter, forming proton and neutron. And the strong force, which is mediated through the gluons, is actually building up the proton and neutron. And this is a very, very complicated process, which is still not fully understood. The dependence of my research is focused on what happens to quarks and gluons at high temperatures and high pressures. At these high temperatures, quarks become quasi-free particles. And I'm interested to see how this happens and when it happens in nature. Well, this is interesting to understand because shortly after the Big Bang, the universe was in a very hot and very dense state. And with the expansion of the universe, the hot and dense state transformed into what we see now. And it's important to understand how quarks and the strong force behave at very high densities and temperatures in order to understand the transition from the early universe to now. Well, I'm a theoretical physicist and also to some extent a computer scientist, and I do large-scale simulation of the strong force and quarks, and I try to make predictions that can be tested by my experimental colleagues, for instance, at CERN. The theory of strong attraction is very complicated, and this is why I have to use a supercomputer, because this is the only means we have right now to solve it. And even on a supercomputer, my simulations can take more than 3 months. I heard a similar experiments. Basically, they also were using ultra-cold atoms and they were bouncing them. The Danish Institute of Advanced Study here at SDU is an ideal place to do exactly this type of research because there's a supercomputer here and there's a lot of inspiring colleagues here helping with the simulations. The Danish Institute for Advanced Study is an interdisciplinary environment that brings also together scientists from other areas, which then can form a very inspiring bunch of people that can think about new ideas and new ways to solve problems in all areas.